You're going to want to write down your conclusions, or my conclusions, on a piece of paper, so that you have a hard copy of them. All right, so here's the structure of your equation, yes? So this is pretty cool. Now, in terms of something that you should have already a sense of, I don't know if you have a sense of it or not, okay? So each of these coefficients has a very specific relationship to the graph itself, yes? All right? So there are a couple that we can get pretty easily. Do you guys know what the A is in this equation right here?
Amplitude.
So it's the amplitude, it's the height of the wave, okay? So the A here is the amplitude, it's the height of the wave. This is going to be important. It's the distance from the top of the wave
The midline.
to the middle. It's also the distance from the bottom of the wave to the middle. So from all the way top to all the way bottom would be 2A. So there's a middle line in every wave. The distance from the middle to the top is the amplitude, or the distance from the middle to the bottom is the amplitude. Is that cool?
Mm-hmm.
All right. What about the D here? What do you think the D is? So the D, because it's all the way at the end, it's the add-on. Yeah, go ahead.
It's the y-intercept.
It is. It really. It's a vertical shift. It's the y-intercept. It's this distance here. Now, the thing that I think is really cool about this is if you look at your other two, their middle line is the time axis. So the D value for the other two is really, really close to 0, right? But here, it shows you how far, basically, it's in this situation, is when this is at rest, and this is the sensor down here, this distance would be D. And then the thing oscillates to below it and above it. That's why you get that up, above, and below. Is that cool? All right. Moment of truth. You guys calculated the frequency, you calculated the period, and then I asked you to do something just random. I asked you to calculate this, 2 pi times the frequency. Did you guys do that?
Mm-hmm.
You did, right? Did it match any of the numbers in your equations?
Yeah.
It did, right? Which one?
The square root of m k.
Well, in this equation.
Oh. No.
Wait, does it match B?
It did, didn't it? All right. It turns out that this B value right here is equal to 2 pi times the frequency. Now, what's interesting about that is that it's also equal to then 2 pi over the period. See how sneaky that is? Because isn't frequency 1 over period?
Yeah.
So that's going to be important. Okay, that's going to be important. Now, the C value here. Let's not talk about the C value for now. We're going to pretend it doesn't exist for now, and then we'll circle back later. Yes.
Isn't C value like the shift or whatever?
It's the horizontal shift. Yes.
Yeah.
Yeah. So far, so good? All right, so let's see if we can't draw, the velocity graph. Now, to do this, okay, you got to use a combination of three things. One, just drawing skills. Two, you're understanding that the relationship between position and velocity is the slope, right? Isn't the velocity value the slope of this one, right? And your like intuition about the way the thing moves. Okay? So let's go like this. We're watching it bounce up and down. When it's at the maximum height, that's the maximum distance from the sensor, what's true about its speed?
Zero.
It's zero, right? If you watch it bounce up and down, it speeds up in the middle, slows to a stop at the bottom, speeds up through the middle again, and slows to a stop at the top. Is that true? Is that cool? So that means that when I start looking at it, when its position is at its maximum, highest above the ground, what's true about its speed?
It's zero.
It's zero. Now, here's what I like about that. If I were to put a tangent line right here, because it's at the top of a hump, what's the slope of a tangent line at the top of a hump?
Zero.
Right? The slope of the tangent line that's horizontal is zero, which means that my velocity value is zero. Is that cool? So you have a sense of that. So that makes some sense to me. Now, the next location would be here, and then here, and then here. So we're going to be out of time. We'll have to pick this up tomorrow. All right, is it Friday?
Yeah.
Who knew?